Hello and welcome to my YouTube channel. Please subscribe for more videos. Today, we will discuss about an introductory course on ASME Standardization and Certification, why they exist and how they are developed. Standards affect your everyday life in many ways, from the plumbing in your household to the elevators in your office place. After this course is complete, you will be able to describe: what is ASME? What is a standard? Why do we have standards? How are standards developed? And how are standards used by an engineer? First, what is the American Society of Mechanical Engineers? The American Society of Mechanical Engineers, also simply known as ASME, is a professional engineering society that serves many roles including hosting technical event, public affairs and outreach efforts, student and early career development, and standards and certification. ASME's mission statement is to serve diverse global communities by advancing, disseminating, and applying engineering knowledge for improving the quality of life and communicating the excitement of engineering. ASME was founded in 1880 to provide a setting for engineers to discuss concerns brought by the rise of the Industrial Revolution. The Society's founders were some of the more prominent machine builders and technical innovators of the late 19th century, led by prominent steel engineer Alexander Lyman Hawley, Henry Rossiter Worthington, John Edison Sweet, and Henry Ford. Today, ASME focuses on technical issues, training and professional development, research advancement, government relations, and other forms of outreach. ASME has a presence within North America and around the world. ASME has over 130,000 members in over 150 countries. We are one of the world's largest technical publishing operations. Next, what is a standard? A standard is a set of technical definitions, instructions, rules, guidelines, or characteristics set forth to provide consistent and comparable results, including items manufactured uniformly, providing for interchangeability, tests and analyses conducted reliably, minimizing the uncertainty of the results, facilities designed and constructed for safe operation. Standards are documents that could help provide a reference baseline for making engineering decisions. They are written using engineering experience and generally accepted practices. Why do we have standards? Standards are considered a common language that benefits manufacturers, designers, and consumers. Having standards helps minimize situations where we could be re-engineering the wheel. All standards promote four key principles: safety, uniformity and consistency, efficiency, commerce, and trade. In the following slides, we will further define these four principles. Around the time of the founding of the Society, many industrial accidents were occurring due to a lack of safety standards and oversight in the industry. One of the accidents that stands out is the one of the SS Sultana. The SS Sultana was a Civil War-era Mississippi River steamboat paddle wheel that contained 4 boilers. The Sultana was used to transport Civil War soldiers, livestock, and cotton. It regularly went from New Orleans to St. Louis. On April 21, 1865, the steamer left New Orleans carrying livestock and Civil War POW soldiers. In Vicksburg, Mississippi, the Sultana made a scheduled stop to pick up more passengers and made a series of hasty repairs to the boilers. Rather than have a bad boiler replaced, a small patch repair was made to reinforce a leaking area. A section of bulged boiler plate was removed, and a patch of lesser thickness than the parent plate was riveted in its place. The repair took less than a day, while a replacement boiler would have taken 3 days. The steamship was way past its maximum capacity. The Sultana had a legal capacity of 376 passengers. It's estimated that after Vicksburg, the Sultana contained about 2,400 passengers. On April 27, 1865, at 2 o'clock in the morning, the faulty boiler exploded while the Sultana was 10 miles north of Memphis, TN. The explosion lit up the sky and was visible from Memphis. It's estimated that nearly 1,600 passengers perished. The SS Sultana is considered one of the worst maritime accidents in American history and is referred to as the Titanic of the Mississippi. The cause of the explosion has been blamed on the faulty boilers and the overcrowding of the ship. The Grover Shoe Factory disaster is significant because it led Massachusetts to establish a Board of Boiler Rules. The board consisted of 5 members to oversee boiler regulations. It was the first of its kind. ASME, in return, formed the Boiler Code Committee in 1911 and introduced the first copy of the Boiler and Pressure Vessel Code in 1915. Today, the Boiler and Pressure Vessel Code is incorporated into laws in most states, U.S. territories, and Canadian provinces. The graph shows the number of boiler explosions occurring during the late 1880s until the 1990s. Aside from addressing steam boilers, a big early problem was that of the lack of interoperability of fasteners. ASME helped set standards for things like screw threads, nuts, and bolts, which made it easier to service equipment with off-the-shelf fasteners. It also played a leading role in the development of important safety standards governing the safety of equipment like cranes and elevators. Some key events in the development of codes and standards include 1880, ASME established 1884, first ASME standard for pressure testing of boilers, 1905, publication of first edition of standard for proportions of machine screw sizes, 1914, publication of first edition of the Boiler Code, 1916, publication of first edition of the Safety Code for Cranes, 1918, founding member of American Engineering Standards Committee, later known as ANSE, 1921, publication of Safety Code for Elevators. Standards help to establish uniformity and consistency among products that you use every day. For example, thanks to product standards, an engineer does not have to concern themselves with who manufactured a bolt to know that it will fit with its corresponding size nut or washer. Another example is that a train can get from New York to California thanks to standardized rail gauges. These are a few small examples of the effect of codes in everything around us. Using standards helps to reduce production time by using existing and proven technology. Standards do this by providing a common language for all stakeholders. Owners, designers, inspectors, and others can ensure consistency and uniformity in the design expectations. Manufacturing to a certain standard implies a high level of quality to the customer. By being consistent and effective in the design, a manufacturer can confidently reproduce existing designs in large quantities. There are various standards development organizations, SDOs, that develop standards for industry, ASME. The international ISO standards, ASTM and IEEE, are all examples of organizations producing standards for the worldwide market. Ultimately, it is the goal for manufacturers to have one standard and one set of criteria worldwide to streamline the manufacturing process. Next, we will discuss how standards are developed. The American National Standards Institute, ANSI, is a nonprofit organization established in 1918. While ANSI does not create standards, they administer and coordinate the U.S. Standardization and Conformity Assessment System. ANSI acts as a clearinghouse, which approves standards submitted by accredited SDOs, designating them as American National Standards. They also help to make sure that no two SDOs are developing identical standards. There are various types of SDOs, such as professional societies, trade associations, testing and certifying organizations, and organizations whose main business is standards development. A professional society is a nonprofit organization seeking to further a particular profession, the interests of individuals engaged in that profession, and the public interest. Some examples of professional societies are the American Society of Mechanical Engineers, ASME, American Society of Civil Engineers, ASCE, and the Society of Automotive Engineers, SAE. A trade association is an organization founded and funded by businesses that operate in a specific industry, such as the American Petroleum Industry, API, or the American Gas Association, AGA. Testing and certifying organizations, such as underwriters' laboratories, perform testing and safety certification on products submitted to them. Some organizations where their main business is standards development are American Society for Testing and Materials, ASTM, National Fire Protection Agency, NFPA, International Standards Organization, ISO. There are several different types of standards. The first type is voluntary consensus standards. These standards are written by industry experts with the intent to benefit the majority of the industry. We will explore voluntary consensus standards in more detail in later slides. De facto standards are those which have become a standard because they are widely used, and the acceptance of them as a standard is determined by the marketplace. An example of a de facto standard is the QWERTY keyboard. Consortia standards are developed by companies that agree to work together to solve a specific market need. Participation in the development of these types of standards is limited to members of the consortia and often requires a substantial financial contribution. Regulatory standards are either written or adopted by government agencies and are enforceable by law. Voluntary standards often become regulatory standards when they are incorporated into enforceable regulations. An example of a type of standard that does not fit into one of these previously described types of standards are company or corporate standards, which are internal documents developed for their own use. Now, let's focus on how standards are developed within ASME in particular. ASME standards are developed by volunteers from industry and government and considered voluntary consensus standards. This means that the standards developed by ASME are approved using a consensus process, which will be described on the following slides, and that their use is optional until it has been incorporated into law or its use has been mandated in a contract. ASME has established and continues to establish various committees which each take part in the development of one or more standards. These committees are comprised of members who are volunteer experts from around the globe from various industries. These experts are the ones who help to keep ASME standards updated to meet the needs of the industry as it evolves. ASME recruits its committee members from all across the globe to be sure that ASME standards are relevant and to understand the local needs of all potential users. ASME standards actions are approved by consensus. Consensus means that there is substantial agreement by the affected interest categories on the proposed action. During the approval process, all views are considered and attempts are made to resolve any objections from the consensus body or any other source. In some instances, it is not possible to satisfy all objections. For consensus to be reached, unanimity is not required. This means that after attempts to resolve the remaining objections are made and the objection still stands, the item can move forward. ANSI procedures require more than a simple majority approval, but not necessarily unanimity. For example, ASME's accredited procedures require a 2-3 affirmative vote of the full consensus committee membership in order for a standards action to be considered approved. There are 3 key principles of the consensus process: openness, balance of interest, and due process. Participation in the approval process is open to all those who are directly and materially affected by the activity in question. Participants in the standards development process are sought from diverse interest categories in order to maintain balance so that not one category can control the direction of the standard. All those who are affected have the right to due process. In regards to standards development, this means that they have the right to express their opinion, have that opinion considered, and have the right to appeal if their suggestion is not accepted. Now that we have discussed how ASME committees come to approve standards actions, here is a glimpse at the big picture of how a standard is developed from concept to publication. It all begins with the recognition of an industry need, engineering problem, or a new idea. Research is then needed to determine what is currently available and what types of solutions, processes are being used, if any. Once it is determined that a standard is the right answer, its development is either assigned to an existing standards development committee or a new one is formed of experts from the related field. The development of the content of the standard can be a very lengthy process, particularly when there are strong opposing opinions. Once the content has been developed, it is sent through the approval process, keeping the key principles of consensus in mind as the action flows through the various levels of committee approval within ASME. Once it is approved by ASME, it is sent to ANC for final approval and then proceeds to publication. Read first 3 bullets. ASME is one of the largest SDOs in the US and the world. ASTM publishes the most standards within the US, but ASME's standards are typically more comprehensive. 4th bullet. With respect to the ISO tags, while ASME advocates for its standards to be accepted internationally, administering ISO committees is one way that ASME helps to ensure consistency and alignment between various overlapping standards around the world. 5th bullet. A growing part of ASME's business is in the certification of companies to conform to its standards. A growing trend is that the majority of these companies are located outside of the US. More on this later in the presentation. Requirements for pressure equipment including boilers, pressure vessels, piping systems, piping components. Safety requirements for elevators, escalators, moving walkways, cranes, man lifts, conveyors, and others. Requirements for nuclear components including containment reactors, piping pumps, heat exchangers, turbines. Requirements for many different things, including hand tools, fasteners, machine tools, dimensioning and tolerancing, performance test codes. ASME is always looking for new areas to standardize, especially when it comes to new and emerging technological areas. Some emerging technologies that ASME is looking to develop standards for are concentrated solar power, thermal energy storage systems, fuel cell performance testing, overall plant performance with carbon capture, nanotechnology, and supercritical pressure technology. The process for developing standards for emerging technologies involves developing the need for the standard. This occurs through discussions with stakeholders such as manufacturers, researchers, and regulators. Typically, ASME needs technical data on these new technologies before any kind of standard can be written. Much of this research is performed through the ASME ST LLC. The ASME Standards Technology Limited Liability Company identifies and conducts research projects to acquire the data for the development of new standards for technology that has not already become commercialized. ASME ST LLC also performs research projects to make sure that existing standards can remain relevant to current industry practices. Now that we've discussed what standards are and how they are developed by ASME, it is time to turn our focus on how standards affect you, the engineer. ASME standards provide requirements and guidance to help ensure that engineers develop safe and functional products. This includes selecting materials for fabrication and construction, providing minimum design requirements, acceptance criteria and procedures for examination and testing of equipment, and guidance on quality assurance programs for manufacturers. ASME standards also provide instruction on how to test the performance of equipment and components, what is required in engineering drawings and other engineering functions. Standards provide requirements on what materials are best suited for a given design application. This includes information related to material properties such as chemical composition, ultimate tensile stress, yield stress, and requirements for material marking and traceability. Standards don't tell you what material to use for your application, just which options are available. It is up to the engineer to select an appropriate material. Beyond requirements on how to select materials for construction, standards provide design requirements. One example of a design requirement that can be found in a standard is the design margin. Section 8, Division 1 of the Boiler and Pressure Vessel Code applies a design margin of 3.5 on the yield stress of the material. In the world of pressure equipment design, standards provide engineers with options for configuring equipment, such as permitted head-to-shell joints and required reinforced for openings in the pressure boundary. Other standards offer design guidance for engineers in other industries. For example, the A17 Elevator and Escalator Code provides design requirements to ensure that elevator hoistways are adequate and to ensure that safety controls are properly designed. Standards also provide engineers with necessary equations to help design safe products. These equations can help an engineer determine a pressure vessel's required wall thickness, design pressure, bearing loads, and many other possibilities. Standards provide the user with only the minimum requirements to make a safe design. Engineers are expected to use their judgment. Standards provide requirements and guidance on what types of material production is allowable. For example, bar stock or welded pipe can be selected for a nozzle. There are requirements for manufacturing tolerances, such as dimensional tolerances on openings in vessels. However, many tolerance requirements are left up to the user and the purchaser to be determined when writing the order specification. Fabrication requirements help engineers determine which types of attachments to use, such as welding and bolting. Guidance is provided on what type of welding to use, as well as what certifications and procedures are needed and how they should be documented. Standards provide engineers with acceptance criteria for manufacturing processes as well, including out-of-roundness and local thin area issues that can occur. This includes requirements on how to address those issues if they are unacceptable. Non-destructive examination is used. Make sure that there are no significant manufacturing flaws. Radiography and ultrasound are used for such things as making sure that welds are solid and determining thickness of metal. Magnetic particle and dye testing check for cracking in the surface. In addition to performing examinations, testing is performed to ensure the design is safe and that the manufactured product meets design expectations. Destructive testing is used to determine physical properties when they are unknown. A good example of this is performing a burst test on an oddly shaped pressure vessel to determine the design pressure when there are no standard equations that can be used. Other types of destructive tests for pressure vessels include gunfire, flame, and drop, which are used to determine structural integrity. Non-destructive testing, such as hydrostatic testing, is performed to ensure that a manufactured vessel will not fail in a range where it can be expected to be operated. Last, standards help engineers by laying out requirements for quality assurance. This includes filling out manufacturing report forms, structuring quality control documents, and marking the final product. Data reports for boiler and pressure vessel codes contain critical design information such as the manufacturer's name, allowable pressures and temperatures, types of welding, and quality control personnel and inspector signatures. The form helps to demonstrate that the code was followed. Markings show that the product meets a certain standard. Elevators, pressure equipment, shower heads, and other products all have markings either attached or stamped on to show pertinent information and the addition of the standard that was used in manufacturing. The ASME Conformity Assessment Sector implements certification and accreditation programs to certify that manufacturers comply with standards such as the Boiler and Pressure Vessel Code. Accreditation is defined as a procedure by which an authoritative body, ASME, gives formal recognition that a body or person is competent to carry out specific tasks. ASME accredits authorized inspection agencies, AIA, which are entities that perform third-party inspection of the manufacturers who receive certification. ASME has product certification programs for boiler and pressure vessel manufacturers, nuclear component manufacturers and quality programs, bioprocessing equipment, pressure relief devices, and reinforced thermoset plastics. In closing, standards have a wide impact on both engineers and the public, often in unseen and unappreciated ways. They make sure that products are manufactured reliably and safely, greatly reducing the risk to life and property of pressure equipment explosions. They also ensure interchangeability of parts and consistency, and ensure fair and free commerce and trade. There are many organizations that develop standards. ASME develops standards using an ANSI-accredited voluntary consensus approach to ensure that standards are developed in a fair manner, with no one interest driving the process or the outcome. Finally, standards are a key resource for engineers. They provide engineers with requirements and guidance on which materials to use, what equations to call upon, how to construct, and how to ensure the quality of products ranging from the simple screw to a reactor or elevator. If you have any questions, please comment. Do subscribe my channel, QC Explorer.